think I fixed the technical difficulties. I have a faster computer. So here we go. This is the bow bracket. This is my second time doing this video because the first time was just horrible technical difficulties. Okay, so there's a lot of sketching on this thing. First, I started here by naming it and putting it in my C drive. Make sure you save all your work to your U drive. So I'm going to start the file. If I need to, I can move this thing around in order to see it a little better. But I'm going to dock it right there. Okay. So the bow bracket. Let's talk about it. The reason I put the bow bracket, it's one simple extrude, okay? It's just a very fancy sketch. And because of the sketch, it makes it a difficult part. Sketching is one of the best ways to do certain features, but a sketch that is too complicated it makes it difficult. This drawing here has, let's just talk about the line around the bow bracket, the outside of it. Okay, if we count the number of lines in this sketch, the outer edge of the sketch, got a horizontal line, then an arc. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 by my count. 16 lines. Now the problem with 16 lines, anytime a sketch gets over about 10 lines, I try to dumb it down because 10 lines takes a lot. Here's why. In order to just draw one line on NX, you have to make a starting point. That takes 2 dimensions, 2 constraints to start the point, to define the point. And then the other point of the line is another 2 points, okay, x, y coordinates, or an angle and a distance, okay, but that's 4 constraints. Now the next line, you already have the endpoint constrained that's attached to it, so the next line you only need 2 constraints on it, okay. If it was an arc, it would need 2 constraints for that endpoint plus a radius. So lines need 2 or 3 constraints typically per line. So with 16, take an average of about 3 constraints per line. 16 times 3 is 48, right? 48 constraints, 48 dimensions, if you will. That gets complicated. Also, so that's 48. If we could dumb the sketch down, make the sketch simpler, then we're doing good. Okay, we lower the difficulty of the sketch. So what we're going to do for this part is we're not going to draw the curved edges around the outside edges. We're going to make all those lines come together at a corner. Okay. Once we extrude the sketch, we can use the edge blend command, kind of like a chamfer command that cuts a corner off at a flat edge. An edge blend command makes a filleted edge. So that's what we're going to do, and that will save us a lot. How many? Well, we have 2, 4, 6, 8 different curves. If we don't have to draw those, don't have to sketch those, 8 times, say, 3 is 36 from 48. There, that's 3/4 of our sketch we don't have to draw, which means it makes it a lot simpler. Also, when you're looking at a complicated sketch, you have to look at it and see, not just look at it, but you have to see and understand. What do I mean by that? When you see an arc, like we do in this corner here, we can assume that arc has to be, the endpoint of that arc on either side has to be tangent to whatever it's connected to, because it looks tangent. Okay, up here, this arc and that straight line, they look like they're connected tangentially, so we have to constrain them that way, not have an arc coming in at an edge, but an arc coming in tangent. So you have to notice those things, and sometimes you have to make assumptions. We look at these 2 circles in that horizontal brace, okay, horizontal piece here, a rectangular piece, and it looks like they are in the center. We have a center line going through it. We can assume that those circles are in the center of the bracket. Okay, that's a logical assumption, which means we have to, if we're going to put a line down the center, we're going to put those circles, those holes on that line, and we're going to make it symmetrical. There's another thing you have to notice, and that is this line right here on the brace here, on the open support. If you were to extrapolate that line downward, notice it goes through this point. What is that point? That point is the center of all these 4 arcs. The arcs are a radius of 3, 2.7, 1.88, and 1.58. They all have a common center. They're all concentric, or they have a coincident point, you could call it. Okay, the centers are all coincident. That line has to lie on that center, otherwise it will not constrain, it will not look the same. So there's a geometric constraint we have to take into account also. When we have this 4x r.30, this dimension, 4x means there's 4 of these. It's a shorthand method of telling you there's 4 of those arcs. On the inside, there's also 4 of a radius 0.13. These 2 arcs are 0.15 also, and these on the far left side are 0.22. You should read every dimension before you start a sketch. Make sure you understand what it's pointing to and what it means. Sometimes there's other symbols in sketches, diameter symbols, or R stands for radius. A circle with a line through it stands for diameter, if you didn't know. We have, if I move this thing over, there's also an angle, a 30-degree angle from that line, or this line since it's parallel to it, to the center. Okay, so let's start. We're going to extrude this part. So let's create an extrusion, and it doesn't really matter what plane we do it on, so let's just pick the horizontal plane. When I created this part, make sure that you start it in inches. This is in inches. How do we know it's in inches? Well, if the drawing doesn't say it's in inches, which a lot of these in the book don't because they were lifted out of old manuals, old drafting books, and when they lift stuff out of old books that are out of print, they don't always take all the information, they just take a picture. That's what they need. So if you see whole numbers, 1.5, 1.22, that's probably talking about inches. And think about the relative size of this part. Looking at it, it'd be about 4.5 inches wide and about 4 inches tall. Okay, that makes sense. If it was in millimeters, that part would be 4 millimeters wide and 4 millimeters tall. Probably not a structural support. Okay, so whereas if you have a part in millimeters, if it doesn't say it's metric, look at the numbers. Typically they're increments of 5, 55, 40, 60, 120. They're typically integers though, and not always, but in the book they are. So this is in inches. Make sure you start the part in inches. There's no easy way I know of to convert an NX part into another unit. Okay, so we're going to start with, let's draw a rectangle. And we're going to do it, the width is approximately, well, it's about, I'm not going to put a distance in. I'm going to tab down, and the height is twice 0.45. So 0.9 high. And notice how small that is. Let's zoom in. And it's going to be about that long relative. Let's zoom in more, and let's move this. Let's escape out of there, and let's move it. I'm going to use this line as our center line, our symmetric line. I'm going to move, okay, so move this back there. I'm going to put a dimension in from here to this line, and double click on that and say that's 0. This one is supposed to be 0.9, sorry, 0.9. Half of that distance from here. And what I'm going to do to make these dimensions a little more relative, just a second, from there to this line, Double click on it, 0.45. Oops, it did not. 0.45. Enter. There we go. Okay, I'm going to finish and save this part. I think if I save it, okay, I'm not going to extrude it right now. I'm going to, do you want to save the sketch? Yes, save the sketch. But it didn't extrude it. And I'm going to save it. I'm going to close it. There may be another way to do this, to reset the dimensions, but I think this will probably do that. And I'm going to reopen it right there. And then I'm going to zoom back into here, and I'm going to double click on that sketch. It did not change the size of the text. Well, that's unfortunate. Zoom out, zoom in. Would have made it a whole lot easier if I had resized it. Okay, I'm just going to move these dimensions way off the part then so they don't get in my way. I don't really know how long this thing is, how wide it is, so I'm just going to leave it there. Using my picture as a sort of a scale, I'm going to now draw some arcs. I'm just going to do the outside arc, the largest arc, and the smallest arc. I'm going to simplify this sketch. So one there, one about here. And then draw some points to connect those endpoints. I'm going to use the extend command. Where's my extend command? Oh, there it is. I thought maybe it was being hidden. It is right here. When you shrink your overall window, the icons sometimes shrink and you lose the text. So since I'm not used to the icons in this version, I need to see the text. I'm going to extend that line and that line. When you use the extend command and click on a line near one endpoint, it extends that endpoint until it hits another line. Similarly for the trim, you can use it to delete a line. If a line, let's extend this a little bit longer. If you want to trim a line, when you highlight it, it trims it back to the last line it intersects. We're going to trim that off too. Okay, let's see if we can get this thing centered or correct. Okay, let's find out where these arc centers are. Let me close this. When I put the cursor on an arc, it gives me a little point so you can see where the centers are. Now they should be on top of one another. So I'm going to go up to here and say concentric. Now the automatic selection progression goes like this. If it's turned off, you have to manually switch between these. You say select motion curve or point. We're finding a point. Excuse me. We're finding a point, and then we're going to make it coincident with the second point. Now if you have 3 points, you can put it on here, click point 1, click point 2, and then you click the point you want it to be coincident to, and then click the point 3. If you do automatic progression, it will toggle between these, usually with 2 items only. It'll toggle between them automatically, so you don't have to be going over here and clicking on it. So I'm just going to use 2 items, so I'm going to use it on automatic selection. And I'm going to highlight that, highlight that. Okay, so I'm going to highlight this. I'm going to go to that point, click on it. Then I'm going to go to this point, click on it. And notice that it moved, right? And then apply it. And now they have the same point. Notice that. Okay? And that point, let's cancel out of here, has a dimension from here to that point. Move your dimension off the part. It's going to get busy really quick. And that dimension is 1.12. 1.12. Enter. There we go. Now it's not quite on that point there, so I have to put that on. I think I can do Let's see, collinear. It says move selected lines to become collinear, so I don't think I can do a point in a line. So I'm going to just do a dimension. I'm going to go from this point to this line. Sorry, let's try it again. From that line to this, escape. Try it again. From this line to that point, double click, and that should be 0. Enter. Oops. It went to the wrong edge. So I'm going to do undo. Let's try my luck again. Let's click this over here. Oh, that'd be 0.45 from that point. Okay, 0.45. There we go. Now we can put in the radius. If a dimension, sometimes when you put a dimension or dimensional constraint in or a geometric constraint in on a sketch, it can warp the sketch. You have two solutions to fix that. You can either grab an endpoint, highlight, grab an endpoint, and move that endpoint and rearrange that polygon that you created. Rearrange the shape so it looks back closer to what it should be. Or you can undo what you just did, whatever messed you up, and put a different constraint in first. So that's two different ways to solve the problem. So let's put in the radiuses. Okay, so all I have to do is click on here. That radius should be, double click, 1.58. Oops, I didn't highlight. 1.58. Enter. And this one, I got a little bit of a lag here. This one should be 3.0. If you type in 3, it understands it's 3.0000. And escape out or hit your control button, which is your roller ball, your center mouse button. Let me pull this thing back to here so we can see it. Let me pull that back so we can see where they're intersecting. Yes, they're intersecting at the same point. That looks better. Okay, let's put in an angle. So if we click two lines and we say we want to put an angle between, we can do this. This would be 30 degrees. And let's get it off the part here. Let's do the same for the other one. And you can do double click. Whoops. If I click and drag this, click, hold, and drag, that could be the angle. You could drag it off this side, and that would be an angle. You can drag it off, different angles. So let's put that in there. 30 degrees also. Now there is a geometric constraint called symmetrical, which is this one. Makes symmetric. This is new to this version of NX. Moves a selected object to become symmetric to a second object through a symmetric line. So let's try that. We might already have this over constrained, but let's take this. Wait a second. Let's go here and pick a select motion curve, and then this one. And here's our symmetry line. And say OK to apply it. So that will keep those symmetrical. If I move one, the other should move also. That looks good so far. Let's do the inner arcs here. And this is a technique when you're sketching. Lots of sketch lines, some sketch lines, different objects in the sketch. Try and complete one closed geometric shape first, okay? And then when that's fully constrained, this is partially defined. Partially defined. It's missing something. What is it missing? Let me see if I can move it. Okay, so when I move this line, it's showing you that it's still movable, so it's not fully constrained. We're going to constrain that when we get more information on this. So let's do another arc on the inside here, and another arc. Now be careful, I don't want to click on that point because the end of this arc is not on that point, and neither is it on this point. So don't make a constraint where it doesn't belong. That may mess you up. So I'm going to go here and really anywhere around here without picking another constraint. There, I guess. And now I'm going to close it by adding lines here and here. Make sure you snap on the endpoints, not on the curve. I don't know if I snap to that curve or not. You can find out by clicking and dragging a line. If the other line goes with it, then you know you snapped on it. Okay, so let's do, you know what? I wanted to do that a little differently. Let me back up, because I want to put a line from this point here through there, and from this point here through there, and then I'm going to trim off. That way I'm killing two birds with one stone. See, I'm getting my line along the edge here, but I'm also constraining that line to that endpoint, even when I delete it. Okay, and let's delete those two. There we go. Okay, let's make some geometric constraints parallel. We're going to make these two lines parallel to one another, and say apply. Don't forget to hit apply. I'm always forgetting that. And these two lines parallel, and then we can put a distance between 0.3. How do we know it's 0.3? Right there, 0.3. So if we go to this line and this line and say 0.3, enter. Watch your little box here. Your text should highlight. If it's highlighted, all you got to do is type it in. If it doesn't highlight, then you're going to have to click on that box and delete what's there. Okay, then I'm going to go from here. Oops. Escape that. Go from here to here. Double click on that and make it 0.3. Let's move that text off here so it gets hard to read after a while. Okay, let's put in the radiuses of those two arcs. So this one would be 1.88, and the larger one is 2.7. Enter. Escape. And of course these center points are not on. Boy, those look really, no, they're close, but they're not on. So let's do a concentric. And let's highlight them both and then go from one to the other and say apply. And they're now concentric, but they're in the wrong spot. So let's make them concentric with the other arc. So again, let's go this one and this one we want to make concentric. So this one and that one, and apply. Cool. What are we missing? What are we missing? Let's try moving something. So I'm going to go to on an edge here and click. You know, that line moved again. I thought when I put that line through there and trimmed it, it would stay there, but it's not. There used to be a command in NX11 called point on a curve, and it was one of these things, geometric constraints, and it's called point on a curve. But I don't see that one. We got a perpendicular, maybe symmetric. They're already symmetric though. Make midpoint. Moves a point to be aligned with the midpoint of a line. This command creates a persistent relation. A point aligned with the midpoint. No, that's really not. When I move this, see, I need that line to go through that. Okay, let me try this. I just got an idea. Let's go from here to here. Arc center. Okay. And then I'm going to go to menu. Is it view? It's one of these tools. Convert to reference line. I'm going to make that a reference line. If it's a reference line, it doesn't get extruded. And now I'm going to put those two lines collinear. There may be another way to do this, but this should work. Now they're collinear and that line is through that point there. That solves that problem. And it says sketch is fully defined. That's great. So I got it fully defined. Now when I put the two holes in here, I know that any constraints I'm missing are related to those two holes. So let's put two holes in there. Can I put it on this line? If I snap on that line, will it one constraint be on that line? I think so. And here's a way to find out. You put them on there, and then you try to move it. And if you can only move it, like I'm moving left and right, it won't move up and down. Good, so I'm constrained to that line. Okay, great. Let's go equal. No, here's equal. Equal length or equal radius. I want radius, so we're going to make these equal radius and apply that. And then I'm going to put, cancel out, then I'm going to put one dimension on there, which is 0.6 diameter. That's what the book says. Now let's move that off here. And now the distances to the center points from here to center point. Notice you highlight the arc, it puts a dot at the center, then you can grab that dot. And let's see, the book says that is 0.6 from the edge, so boy, I got close to that, didn't I? That was cool. And then from this line to that is, what does the book say? It's 1.5. Let me double click. 1.5, enter. There we go. That should now be fully constrained again. Yes, sketch is fully, the term used to be fully constrained. Now they say fully defined. Everything but the arcs, right? So I finish it. I'm going to say extrude. Let's say 0.5, that's fine. I don't know what the thickness is. Great, that's good. Now let's put in, now we're going to round the edges. That is the edge blend command. In the edge blend command, you can do one or more points. Since this is already at radius 0.22, since I did this the last once before, that's okay. Apply it. Now again, remember, if you say okay, it applies it but stays in the edge blend command. So I'm going to do that because I have more edge blends to do. If I say apply, it just applies it. Sorry, if you apply it, it just applies it. If you say okay, it applies it and then cancels out. If you hit cancel, it just cancels out without doing anything. So we're going to say apply it. Then we're going to go to these four. and we're going to make them 0.3, and we're going to apply those. Then we're going to go to the inside ones, and if these were too large, if this inside slot was too narrow and you couldn't fit a 0.3 in there, maybe it only fit a 0.1 or a 0.1, 0.5, it might give you an error. Don't worry about it. These snowflakes are saying, okay, so good so far. But we're going to go 0.15, and actually the other ones are 0.15 too. Now you could pick these, or you can make them different. Okay, if you apply those two, then if you want to go back and redo that, or if I want to redo the outside ones, I'd highlight it, right click and say edit parameters. I can now change those. If I go to the inside ones, I'm going to be changing all 6 of them. Okay, so if you knew that in the future you might want to change the inside ones separate from the outside ones, then don't connect them all in one command. The edge blend command also works, and other commands kind of work this way too sometimes. Edge blend, you can have a filter, and up here is where's the filter? Right here. It pops up when it possibly is needed. If I wanted to filter if I grab an edge here, this says tangent curve, so it's going to pick this edge, and it looks at the endpoint, and if there's a tangent line at the endpoint, which there is, it should grab that line, and then the next line, and the next line, and it'll keep going as long as it finds tangent curves, if it's on tangent curves. So let's see if that works. There we go. It's working. It would stop if it didn't hit a tangent curve. Sometimes you don't want to do that. Sometimes you want it to go a single curve, so you can pick just one at a time. You'd have to work your way around all the way around. Okay, see why it's easier if you have a filter to change that. What else they have? They also have connected curves. So if you have a square or rectangle edges you want to do, if they're connected but not tangent but connected, they'll follow the edge all the way around too through corners. You can also do face edges. Sometimes I do this. If you want to do every edge on the face, probably going to have to make this smaller, 0.05. And you pick a face, it rounds everything on the face. A lot of parts never have actually corners, okay? After the part is cast, it might actually go through a media, what do I want to call it? A buffing medium, not a buffing, a grinding? No. They put it in a media like walnut shells or something, and it vibrates, and it takes all the burrs and the edges off, any sharp edges. And sometimes that'll basically round things off. That's what they do to dice. Okay, you get a 6-sided die. Typically they are cubical, and then they put them in a media of hard pellets or something other media, and they vibrate it, and random chance everything gets vibrated the same, so the corners slowly get ground down. The longer you leave it in there, the more rounder the edges get. Okay, so if you want to play with that, that's fine, but that part is now done. Let me hit isometric, and that's what it should look like when you're done. The last video, okay, I already did the L bracket, so you can find that on the YouTube site. The next video after that, I think I've already done that one. I just haven't edited it. The last video in the set, which is number 10, is telling you how to hand this in, how to populate a template and send me a PDF of that by email.